Hey guys, so in today's lesson we are going to look at 11-5 two-way frequency tables. Okay, so we're going to look at tables and we're going to do some frequency stuff with them. So Miss Holman and Miss Bean collected data from their algebra classes. So do you guys remember it was like 2 weeks ago, but one of the attendance assignments was like, what's your favorite drink? What's your favorite sport? We had a couple different ones, but right, and some of you guys chose tea, some of you chose water. So that's what we're looking at. That's why I collected that data, so we could use it. So we're going to use the data to calculate and interpret joint and marginal frequency, joint and marginal relative frequency, and conditional relative frequency. And you'll learn all those words as we go along today. Okay? So, Miss Holman and Miss Bean were planning an end-of-the-year party for their classes and wanted to buy the correct drinks. So students were asked to choose one of 3 drinks, complete the two-way frequency table to organize the data. What do the trends suggest? So out of the 83 students surveyed, 51 were male. So if you come here, okay, male, the total number of males is 51. And we had 83 students total, so 83 goes in the bottom. Of 18 students who chose tea, so 18 students chose tea in total, 7 were female. 16 females and 26 males chose water. So, okay, we've got 16 females, 26 males. And 23 students who chose soda. So we have 23 students in total that chose soda, but 14 of them were male. No students were able to choose more than one drink. So we can actually use all these values to figure out the blanks in our table. Okay, there's a couple blanks, but we can figure it out. All right. So let's start here at the total number of females. So we have 83 students in total, but 51 are male. So what we're going to do is we're going to take 51 plus this question mark. We're trying to figure out how many females there are, right? So an 83. Now we're going to solve for the question mark, and we're going to subtract 51 on both sides. That goes away. So this question mark is equal to 32. So there were 32 females total surveyed. Okay, now we can kind of keep going, and we can figure out the males that selected tea pretty easily as well. So what we're gonna do, okay, is we're gonna follow the same process. We're gonna do question mark plus 7 is equal to 18, which is the total number of students that chose tea. So we're going to subtract 7. We're going to solve for the question mark, okay? Subtract 7, and then x is equal to 11, or question mark is equal to 11. That was 7, okay? So the 11's going to go there. All right. Now we also need to figure out, okay, total number water. So we can just add, like to figure out how many students in total chose water, you can just add these together. And 26 plus 16 is 42. So 42 goes there. Okay, last box we got to figure out is this one, okay? And I'll change colors. That one. Okay, but same process, okay? We have 23 in total, but 14 are male. We just need to figure out how many females there are. So 14 plus the question mark is equal to 23. So we're going to subtract 14 from both sides. And question mark is equal to 9. Okay? So question mark is equal to 9. That means we have 9 females that chose soda. Okay. Something I want to severely emphasize is that 11 male students chose T. Okay, 11 male students chose T. Okay. Joint frequency. Okay. Joint frequencies. Excuse me. Joint frequencies indicate the frequency of a single option for one category. Okay, so it would be like males that chose T. A joint frequency let me rewrite that. Okay, is at the joint of a column and a row. Okay, so right here, where male and T come together, 11, that's where you're going to find your joint frequency. Okay, guys. So I actually typed it out here if you have problems reading my handwriting, okay? Joint frequencies indicate the frequency of a single option for one category. A joint frequency is at the joint of a column in a row. Okay, so for example, like I said, males that chose T or males that chose soda. So it's when this is a column, or columns go up and down, rows go left to right. So it's when the row meets the column. Okay. So, marginal frequency. Okay, let me write that out. Marginal frequency indicate the total frequency for an option or category. A marginal frequency is at the margin or edge of the column. So the joint frequency, okay, in this table would be like 18. So the total number of people that chose T, or 23, the total number of people that chose soda. Or marginal frequency is also the 51 total males or the 32 total females. Okay? So marginal frequency is on the edge. Joint frequency is going to be in the middle. Okay. So joint frequency suggests that males prefer what over soda? So, if you look here at the table, soda was 14. Between tea and water, which one was greater? Water. So, suggests that males prefer water over soda. Okay, the marginal frequency suggests that all of the respondents prefer blank over blank and blank. So, which out of all three, now it said all the respondents, so not just male, not just female, but all of them together. So we need to look at this last row, right? And it said marginal. So we're definitely going to look on the outside. Which one had the most? So water. Water had the most. So people prefer, all of my students, all of Miss Holman and I students, prefer water over soda and tea. They also indicate that more males than females were surveyed. Now you can look and find that at the table, okay, total number of males that were surveyed was 51, but the total number of females that was surveyed was 32. So we had a lot more males respond than females. All right, guys. Okay, guys, so let's move on to example 2. Okay. I also want to emphasize, before we move on to example 2, that joint frequency, okay, it indicates the frequency of a single option for one category. Extremely important definition. Joint frequencies indicate the frequency of a single option for one category. Okay? All right, guys. So, okay. This summer, Miss Bean were planning an end-of-the-year party for their classes and wanted to buy the correct drinks. Students were asked to choose one of 3. What do the survey results reveal about male and female students' preferences? Okay, so joint relative frequency is the ratio or percent of joint frequency to the total. So we're going to put some of those joint frequencies, and we're going to put them over the total. So marginal relative frequency is the ratio or percent of the marginal frequency to the total, okay? So we're going to use the same numbers. We're not going to change anything. So remember, we had 83 total, okay? So for males that had T, we had 11. And to find the joint relative frequency, we're going to put it over the total, which is 83. 11 divided by 83 was 13%. So 13% of the total. So for soda, we had 14 over 83, and that's equal to 17%. For water, we had 26 over 83, and that is equal to 31%. Okay. Now we also had 51 males in total. So we had 51 males in total. And we're going to put that over the total amount of the population. And that's going to be over 83. And that equals to 61%. So 61% of the people that responded were males. So we're going to keep going with the females. We'll have 7 over 83 because we had 7 that chose T. And 7 divided by 83 is 8%. Okay. Then we'll have 9 over 83 because that's how many chose soda, and that's 11%. Let me close that up. Okay. Now for water, we had 16 over 83. And that is equal to 19%. So the joint relative frequency of females that chose water is 19%. I'm going to repeat that again. The joint relative frequency of females that chose water is 19%. Okay. Now let's do females. So 32 over 83, because we had 32 females that responded, and that's 39% of the population. And if you'll notice, 61 plus 39 is equal to 100. So that would be 100%. So, all right, let's just finish up the table. We've got 18 over 83 is equal to 21%. 23 total people chose soda, and put that over 83. That means that 28% chose soda. And then for the last one, 42 people chose water. So 42 over 83, that equals 51%. And the very last box is 83 over 83. And that's 100%. Okay, guys.